Okay, so I'm just going to put a little demonstration up to show why a UCS is important and what it really means. So um, you have to think in Bobcat about it's kind of like their drawing tools and everything is in paper space. So for instance, this right here is in the UCS we're active in is the top UCS, which would be as if there was a paper right here. So think of there's a big sheet of paper, right? So if I wanted to draw um, here up and up and I mean, where is that? It's off in really infinity. So you kind of have to tell um, you have to tell Bobcat where you're drawing, and you do that with the UCS. So like a front view, so like here's a 2D drawing right there, and everything you click on is going to happen in that 2D plane of the top view. So for instance, if I just took one of the spline tools and I click here, um, I can do that, right? And everything there happened at that same plane. So what happens if, say, I switch to the front view and now I'm looking down on the end of that thing, but how do I draw like this? Because if I start clicking now, everything's going to be happening on this 2D plane. So that's where you'd have to switch to the front view. And what that means is you're basically flipping your paper. So here's the same plane I put in the front view. It's basically just I just drew a plane there. So now if I switch the top one on too, you see that that's the front view. So you would the way to and if I want to draw now, I can draw in that plane that's in the X and the Z direction. So if I flip here, so I can turn that plane off. It's just on a layer. And now if I go to my UCS and I switch to the front view, see that like that, that purple thing is the representation of the UCS. Now when I take my drawing tools out and I draw around, right, it's basically the same drawing, but what I did was draw in that space there. And then, of course, the last one is, that would work for the side also. So if you were looking at this and then what if you wanted to draw, if we switch to the right view or whatever, there we are looking at it from the right. How do we draw like this? But every click we have, if we're in the top UCS, is going to be happening there. So really, that would be kind of like right through that straight line down there. You couldn't draw up here, for instance, because that's just out in infinity again. So you would switch to the side UCS, which looks like that. Now all my drawing is happening there. Now all we've done is everything from 0 right there. So that's where making a custom UCS comes in. So I defined a custom UCS. Like what if you wanted to draw out over here, for instance, right? So there's a paper plane I want, What if something was out here and you wanted to use the 2D tools there? Well, same thing, I added a custom UCS by 3 points to that area right there, right? So you see how that purple thing moved over there? So now um, my 2D drawing tools and all my functions like adding arcs and everything are working out there. And so uh, it's basically the same thing. So if I switch back to the top view and I get rid of that little plane I put out there just for reference, you'll see that I drew that drawing out there. So that's why a UCS is important, and so I'll show it to you right here in this 2D drawing, which is basically somebody asked, what happens if you wanted to make a 3D surface in this area, and I want to put an arc on this. Well, if we're just in the top UCS, right, and we go to the arc command, say, and we're going to snap an arc, and that arc is going to be 0.0625. It's half of one. This is 0.125. I could measure that line, but it's an eighth of an inch stick there. If I wanted to snap that arc onto here, it's going to snap in that top UCS and just be flat with everything else. But if I want it going down in Z, what I have to do is switch to the front UCS, right? And now when I snap there, it's going to be drawing in this direction, which is the X and the Z. So I could just put a half arc there. I could change the start angle here to 180, so that would be a half arc, and then I have a center snap point on that. So if I do that, I have a little half circle there uh, drawn in the Z. And so same thing now, if I want to extrude that, I can't be doing it from the from the top UCS. That would be as if it was that 2D paper space. If I want to extrude it this way, like towards that Y direction, then I'll switch to the front UCS, and I can go to the extrude curve tool, 3.125, and then I can also switch. I can also switch to make sure I go along the Z-axis. Then I can pick this. Now I'm extruding it in the Z, which is actually towards that stick now by 3.125, and that extrudes the surface in that direction. And so, oh, I got to keep this. Recording software makes it tough to deal with. So now I have this surface there. It's a 3D surface that I can use for one of the 3D toolpaths. And so I already made a couple. Here's a 3D slice planar, for instance, and I named it 1/8 inch deep because that's what this, it's actually 0.0625, half of an 1/8 inch diameter thing. So I can just select that geometry, and I've already set this up, so I'm just going to, compute that toolpath. So now I have a 3D toolpath that's going down in Z because that surface depicts that. And the toolpath just follows it with the parameters I set. The parameters in the toolpath are, they're not, you can't set any depth parameters. Their depth is comes from that surface right there, determines what the toolpath is reading. Cut amount isn't a depth. It's a, see, that would depict what it is. It's the step over of the tool. So if I put a cut amount of 0.004 on this, that's these little steps here. It goes all the way down, then it steps over 0.004, it comes all the way back, blah, blah, blah. So now if I wanted to make that deeper, then what I would do is the surface would have to be made deeper, either a bigger, deeper arc by drawing it, or I could also translate. Let's copy that one down. Let's send that down by minus an inch, okay? And I'm going to do that. So I'm making a copy of that. Oh, and see, now I did it from that front UCS, so it went down the wrong way. So I didn't switch back. What I want to do is be working from the top UCS now, because I want to translate that down in Z. So I'm going to reselect that now. There's my copy. So that's that tiny little surface is now 1 inch deep in the Z value. And so I don't have to change any parameters. I can come over here. Here's the exact same one. I just select that geometry, right? And I can toolpath that one. I actually just changed the slice angle. So this one is an angle of 90 degrees. It's going back and forth this way. This one I made it 0. So the toolpath is going back and forth and back and forth at that 0.04 step over. So now that cut is happening at an inch deeper than this one above it. And you can even tell that because you can go into this one right here, has a step down parameter. So you can step down at 0.05, however many that'll make it. Now if I recompute, that thing's going to put a bunch of toolpath all the way down, stepping down, so you're like cutting into the material, stepping down at 0.05 and making that same pass all the way down till it gets down to the depth of the cut. So that's how to make, the toolpath with 3D geometry is defined by the surface structure. And that's what using your UCSs is for being able to draw in different dimensions than just that sticking with that top UCS. Okay, I hope that helps.